so we're going to talk relations and functions, conjunction, junction. What's your function today? Okay. Let's do this. So, a relation. Now, we all have relations in life. Okay. We all have relations in this room. Okay. Right? But in math, there are some different ways to represent a relation. Okay? And a relationship, or a relationship, whichever one you want to go with, is where you pair two things together. Okay? And in this case, in the case of chapter 2, and really in the case of all of algebra, we are going to pair an input with an output. Okay? So we're going to pair together, we're going to take a number, and we're going to put it into a relation, and out of that relation is going to come the output. Okay? Now, we don't like inputs and outputs. That sounds kind of cheesy a little bit. Okay? So they went and they mathicized it. Okay? So our inputs, we're going to call domains from now on. The domain of a relation is the set of all inputs. Now, I see some people taking notes on their graphing sheet. Remember, your graph paper is for your homework tonight. Okay? You should be taking notes on a separate sheet of paper right now if you need one. Because that's your homework.
It's just me.
Okay? You'll see my logic later on in life. I promise. I promise you will. Okay? Right? So the set of all inputs. Range, then, is the set of all output values. Now, normally, we're going to be dealing with that dreaded F word, functions. Okay? We're going to be dealing with functions. And normally, the domain is the inputs, which is the x's, the x values. Okay? The range is the outputs, which is the y values. Okay? So from now on, domain is x values, range is y values. Okay? All right? Now, there's a word in there called set. Okay? All right? Set notation is a little goofy. Set notation has these fancy things on either side of them. And so if we were giving the set notation, we would say the set of all points such that blah, 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 blah. Okay? All right? Now, my non-artistic brain, okay, can draw one of those at a time. Okay? I can either draw the left one or the right one, and I screw up on the other one. Why? I don't know. Okay? But I can't do both of them at the same time. Okay? It's one of my quirks. So, if you need to make set notation, but you can't do those funky things, then you have to do it the Linz way. Those look almost identical. Okay? Alright? So if you need to squiggle, squiggle. Just make sure you put a bunch of squiggles in there so that it doesn't look like a number in particular. Okay? Alright? So make sure you're doing a bunch of squiggles in there. Okay? Alright? And I am okay with either one. If you can draw those things, hey, you're gold. You're aces in my book. Okay? Alright? But if you can't, make sure you're drawing the squiggle. Okay. I'm jumping around all over the place. Alright? Now, there are 4 different ways to represent a relation. Okay? 2 of them you have seen. Okay? 1 of them you hate. 1 of them you've never seen before. Okay? I know this. Just took a little peek inside your brain. And I said, yeah, 2 of them they understand. One of them they don't like. One of them they never see. So, the one that you've already seen, we could represent a relation as a list of ordered pairs. So we can just straight up list them out, write them out. That's our relation. That one you've seen. Okay? Now, in terms of these 4 different ways, I always will represent, or the set is always going to be the ordered pair 4, 2, 3, -1, -1, 5, and 4, -1. Those four points are going to be represented in the 4 different ways. So I didn't change that so that it looks funky or anything like that. Okay? The second way is we could make a table out of those 4 points, where we put our x's in one column, 4, 3, -1, 4. Then we put the corresponding y's in the other column, 2, -1, 5, -1. Okay? Those are the 2 that you have seen before. Okay? What do you want next? The one that you've never seen before, or the one that you don't like? Let me ask that again. Which one do you want next? The one you haven't seen before, or the one that you don't like? The one that you don't like. Good choice. That way I only have to come this way. Okay? The way that you don't like is I could graphically represent that relation. Because it's a way of representing a relation. That's why I told you don't like it. See, again, I peered into the future, Colin, and I said, I know that kids don't like graphing. Okay? But guess what we have to do tonight? Graph. That's why you got graph paper. Crazy like that. Okay? So, a graph could be a function. You could draw something on there, a parabola, a line, a circle, whatever. Okay? It could just be a set of points. Now, in this particular case, because my relation was just 4 points, that's all that goes on my graph is 4 points. I don't connect them with anything. Okay? I just have 4 dots on my graph. Okay? If this were an equation, then I would connect it. But if it's a list of points, it's just that. It's just points. Don't connect them. Okay? And the fourth way, the way that you haven't seen yet, is something called a mapping. Okay? Now, a mapping takes all of the elements of the domain and it puts them in a circle or a box. I don't care. If you want to go box, go box. Okay? But if you go a circle, make sure you get all of them in there. Okay? Then it takes all of the elements of the range and puts them in another circle. And then you just connect those elements as they see fit. So, the point 4, 2 is represented in this mapping with the purple arrow. 3, -1 is represented with the yellow arrow. -1, 5 is represented with the orange arrow. And 4, -1 is represented with the blue arrow. Now notice one thing about both the domain and the range in this relation. There are 4 points in this relation. But in the domain, there's only 3 numbers. Why? Why are there only 3 numbers in my domain. Remember, domain is the x's. Oh,
4 is twice.
because 4 is repeated, right? Okay, so 4 is repeated. We don't put repeats in our domain or in our range. Okay? We don't put repeats in there. Okay? We just list out the raw values of the numbers. Okay? All right? Any questions on mappings? You'll have to do a few in a little bit. Okay? So, well, I guess you're going to have to do a few right now. Okay? So the first question is, find the domain and the range of this relation, and then draw the mapping of that relation. Okay? Well, the domain, and we can represent domain with a big old capital D. Okay? So the domain, that is the x values, okay? So I'm going to draw myself a squiggle because it's set notation. What are the x values in my domain? Or in my relation? X values. X values. Does everybody remember how a point is written? What? What's the domain? What's the set of my domain?
2, 5, -3, and 8.
Do we agree with Colin? 2, 5, -3, and 8.
Yeah.
Yeah? Because that's the x. Because remember, points are x comma y. Right? Okay? Now, Colin, would you be offended if instead of me writing it as 2, 5, -3, 8, that's okay. Would you be offended if I wrote it as -3, 2, 5, and 8? What's the difference between yours and mine? Mine is numerically ordered. Okay? Makes it easier to figure out what it is. Okay? Does it have to be that way? No. Does it make it easier? Oh yeah, big time. Okay? Okay? Range, then. What is the range of my function or of my relation?
-1, 4, and 7.
-1, 4, and 7 says Sam. Do we agree with -1, 4, and 7? Yep. Now, what if I wrote -1, 7, 4, and 7? Is that right or is that wrong?
Right.
Give you another chance. That's wrong. Yep. Yep, that's wrong. Because the 7 is repeated. Okay? We don't repeat them. Okay? We could write it as -1, 7, 4, but we just wouldn't repeat that 7 then at the end. Okay? So I don't care what order those 3 numbers are in, but I only want 3 numbers there. I don't want the 7. I don't want the second 7, is what I'm saying.
Wait, you don't care if it's numerical on the range?
I mean, I prefer it numerical, but I'm not going to take off for it if it's not numerical. Okay? That's what I'm saying. You know what I mean? If for somebody else, it's easier to read it if it's in numerical, but you know what I mean? Okay? So, a mapping now. Let's make ourselves a mapping. So I take the 4 elements, -3, 2, 5, and 8 of my domain, and I put them in a big old, we'll call it an oval. And then I take my elements of my range, and I put them in a big oval. And then I draw myself some arrows. So 2 goes to -1. Shabam. There's 1. 5 goes to 7. Shabam. There's another one. -3 goes to 4. Shabam. There's 1. 8 goes to 7. Shabam. There's the other one. And that, ladies and gentlemen, is my map. Okay?
Why don't we ever do a mapping? I don't really like it, but like, why don't we do it? Why is this the first time I'm really seeing it?
Because really you only see it, you can really only do a mapping with points when your relation is just points.
And
We're
usually
gonna-
just do something else, like an ordered pattern.
We're gonna move away from points here in a little bit, and we're just gonna go to equations, to function notation and functions. And so then you can't do a mapping with a function because there's the domain is all real numbers. So you can't really write down every single number that there is. Okay? Conjunction, junction, what's your function? Okay? So a function is a special kind of relation for which each input has exactly one output. Okay? Each input is paired to exactly one output. Okay? Each element of the domain is assigned exactly one element from the range. Okay? Now, that's great. I love it. But that's book speak. Okay? And for those of you that know me, I'm not a book speak kind of a guy. I'm a straight shooter. Okay? I tell you how it is. Okay? Sometimes you may not like it, right, Colin?
That's right.
Okay? But sometimes truth hurts. Okay? So what that means in straight talk is there are no repeated domain elements. Okay? So basically what I'm saying is there's no repeated x values. That's what makes a function a function. Okay? Every x value is different. Okay? That's what makes a function a function. So we can look at relations and we can say, well, is it a function or not? We look at the x values. Well, here's an x value. Here's an x value. Here's an x value. And there's an x value. We look at those x values. All of them are different, right? 3, -1, 2, and 4 are all different. So this is a function. Okay? I can have repeats in the range. This is okay to have repeats in the range because that's y values. I just can't have repeats of the x values. Okay? So here in letter B says, oh, we got a repeated -1, right? So this is not a function. We can evaluate functions at any value of x. Okay? Oops, tap the brakes. I forgot. I was supposed to go like this. And I was supposed to talk about linear functions here first, because then that brings in function notation. Okay? So, a special kind of function is something called a linear function. Now, a linear function graphs into a line. A linear function has a constant rate of change. Normally, a linear function looks like y equals mx plus b. Okay? So we can make that change. Okay? So a linear function normally looks like y equals mx plus b, but we can write that in what's called function notation. So if I take y equals mx plus b and I write it in function notation, I replace y with f of x. Okay? So in xy notation, it would be y equals 3x plus 5. The exact same line in function notation is f of x equals 3x plus 5. Those two are saying the exact same thing. One is just written in xy notation, one is written in function notation. And we're going to deal a lot in the world of functions. Okay? Just remember, it's not fx. That's a TV channel. Okay? fx has the movies. Okay? It's read f of x. Okay? So, we can evaluate those functions now that we know what function notation is, or remember what function notation is. We can evaluate those functions. So I can give you a problem that says something along the lines of, if f of x is equal to 3x minus 4, then f of negative 2 is equal to what? Or find f of negative 2. Okay? Well, what you're going to do is you are going to replace x with negative 2. As you can see here, I replaced x with negative 2. So that means on the other side of the equation, I am going to replace x with negative 2. And now I simply do the math. 3 times negative 2 is negative 6 minus 4 is negative 10. So f of negative 2 is equal to negative 10. And that's my value. That's my output value. Whoops, taps the brakes. That's my output value if I input negative 2 into my function. Okay? So the point negative 2 comma negative 10 would be on that line or on that function. Okay? I'll give you 2 to try now. Okay? Whoops, tap the brakes. Oops, now I went too far. There we go. Whoa. That's not what I want. Maybe it's option. Now it's going. Ay caramba. Learning stuff. Alright, so h of x is that. I want h of 4. So I am going to find h of 4 is equal to 2 times 4 plus 6. 2 times 4 is 8, plus 6 is 16. So h of 4 is equal to 14. I might have said 16 there, but nobody's really paying attention anyway, so nobody called me on it. Okay? Alright, and then the last one, we can put it into a quadratic function also. Okay, so j of 2 is going to be 3. Oops, tap the brakes. That's going to be 3 times 2 squared plus 6 times 2 minus 5. That's going to be 2 squared is 4 times 3 is 12. 6 times 2 is 12. 12 plus 12 is 24 minus 25 gives me j, gives me j of 2 is 19. Okay. Cycle back a little bit. Okay. Function, not a function. You don't even have to write this one down. Okay? Just look at it and tell me function, not a function. Yes? Why? X doesn't repeat. Negative 3, 1, 4, negative 1. No repeats there. Function. Love it. Function, not a function.
No.
Why not?
Because there's 2 ones.
There's 2 ones. Yep, so it's not a function. Okay? Quick little spot check for you. All right? How can I tell if what I'm looking at, if my graph, and sorry, Colin, I know you don't like graphs, but we have them in life. Okay? So how can I tell if my graph relation is or isn't a function? Well, let me put some graph relations on here. Let's go with a cubic. We'll just go with a linear. And then let's go with a cycloid. Okay? How can I tell if those are functions or not?
If 2 points aren't like above or below each other, like directly.
Okay. So give me a way that I can go about, like, what? I like vertical instead of straight. Yep. Okay. So I can do the vertical line test, which is basically what you were saying. Yep. Okay. Now for you, you've got many different vertical lines at your disposal. Sitting right on your desk right now, you've got many different vertical lines. Okay. You've got a pencil. You could take and fold over your piece of paper. Dietz is using her phone. Okay. All good. Folders, rulers, calculators, okay? Lots of different things. I don't have that luxury, but I have a line maker. Okay? So I can make myself a vertical line, and I can slide it across the graph. And if I slide my vertical line across the graph, my blue line, or my blue relation, I should say, should only touch my red vertical line in one spot. So this one is a function. Okay? My middle one, my linear function, is a function. Okay, slide it all the way across, only touches once. Whoa, Nelly! We got some issues going on here. Because if you look at this one touches once, twice, 3, 4, 5, 6, 7, 8, 9 times. So that one's not a function. So the first 2 are functions. The last one is not a function because it fails the vertical line test, the VLT. Okay? Now, we're going to graph lines here in 2 minutes. Watch me go. Okay? So, one way to graph a line is you could use a graphing calculator. But that's really not going to help you because you're still going to have to transfer that onto your paper, and that's just not going to be very easy to do. So graphing calculators are out there. You can use them, hey, great, but they really don't help you. Okay? Another way, you can always make a T-chart where you pick some x's, then you plug that into your function, and you get out some y's, and then those become ordered pairs. Okay? Even easier than that is if you solve for y and put it in y equals mx plus b form, then this b here is my y-intercept, which is the point 0, comma b. And my slope here is m, and slope is rise over run. So we take that slope and we rise it and we run it and we plot other points in it. Okay? The fourth way is you could do it the intercepts way. If you set x equal to 0, that's going to give you the point 0, comma, some number. That's going to solve for y. That's going to give you the y-intercept. If you set y equal to 0, that's going to give you some number, comma, 0. That's going to give you the x-intercept. And you only need 2 points to make a line. Okay? So that's another way of doing it. Okay? Let's quickly do one. Okay? So if it's in function notation or if it's in y equals mx plus b form, okay, either way, this is my y-intercept right here of positive 2. Up to, put a dot. My slope is negative 3. Okay? So I'm going to go down 3 and to the right 1. Oops, tap the brakes. Down 3 and to the right 1, and so on and so forth. And I'm going to keep going all the way across my graph. If I don't like going down and to the right, I can go up and to the left. And so on and so forth. Then I'm going to take that straight edge that I was using before, and I am going to utilize it as a tool to draw my lines straight so that I don't have wavy lines. Lines are straight by definition. So make yours straight. Use a ruler, use an ID, use something. Okay? Sit down and write down the homework before you get up and leave. Aye, aye, aye. Okay?